What I am about to put up on the board, what we're about to talk about, is the heart of what you have to understand about derivatives, about differentiation. Okay? And here's how it's going. I'm going to do it all from off the top of my head, so if I forget something, I may have to look at something. But here's the heart of everything that you have to know how to do. Okay? For any function, okay, which we will call for now f of x, we want to be able to identify, given various pieces of information or given any one piece of information.
Can we write this on our folded sheet?
No, I would write it in your notes. Yeah. But on the folded sheet, you're actually going to do what I'm about to write down here to 4 different functions on the folded sheet. Okay? For any function f of x, you should be able to identify the critical values. The critical values of that function. You should at any time, I or a test or some person questioning you in calculus knowledge should be able to say, hey, here's a function. Okay? Here's a function. What are the critical values of that function? Now, the critical values are related to the minimums and maximums, the relative minimums and the relative maximums. Do you remember that?
Yeah.
So, you should, for any function, be able to identify the relative minimums and or the relative maximums of that function. For any function, you should just be able to look. Somebody should be able to hand you a function and say, hey, here's the function cosine of x over e to the x. Can you tell me where the relative minimums and maximums are? Okay, now there's probably a lot of them because it's a cosine function, but maybe they'll say, hey, can you tell me where all the relative minimums are between 0 and 10? Okay, on the interval, the x interval from 0 to 10. Okay, so you should be able to identify all the critical values, all the relative minimums, and all the relative maximums. You should be able to identify where the zeros of that function are. Now, this actually isn't even calculus, identifying the zeros. This is actually algebra. Now, using either a calculator or using some other technique, like the rational root theorem or synthetic division or some kind of, if it was a quadratic, you could use the quadratic formula to find the zeros. Yeah?
We're going to use the back.
No. Yeah, so you can take the notes on the back if you want. You should also identify, in addition to the zeros, and really I should have put that first, but you know what? It is where it is. You should be able to identify where the function itself has positive values. Where is it positive? Where is this graph above the x-axis? And again, that's algebra. This isn't even calculus. This is algebra. But you should be able to do that. You should be able to identify where the function has negative values, where the graph is below the x-axis. Again, this is algebra. This isn't even calculus. Now, it becomes calculus when you find the derivative and then find where the derivative has zeros, where the derivative is positive, and where the derivative is negative. Because the zeros of the derivative tell us what? Anybody remember? It tells us what?
The original function.
And what do we call that is already listed here? The critical values. Because the zeros of f prime of x, if you can identify the zeros of f of x, you can identify the zeros of f prime of x. Right? And the zeros of f prime of x are the critical values of f of x. Okay? I don't know, is this all the knowledge now balling together in one place? I mean, I hope you eventually start to feel that. I've said it before, I don't know if I said it in this class, but you must understand that calculus is one body of knowledge. It is not a bunch of different subjects. It's a single body of knowledge that all the topics reinforce one another. Okay. We're ready for the next couple parts? you should be able to identify where f of x is increasing or decreasing. You should be able to identify where a function f of x is increasing or decreasing. We're almost done. There's only 2 more things I'm going to put up here. Only 2 more things. And when I put those 2 more things up here, that will be everything that you should be able to identify about a function in a calculus class, and that is the heart of all of differentiation. Yes, that's exactly right. Yep. All right. You should be able to identify where there are inflection points. You should be able to identify the inflection points on f of x. And lastly, you should be able to identify where f of x is concave up or concave down. If you can accomplish this, if you can accomplish all these things, then you can do everything that you need to be able to do with respect to derivatives or differentiation. This is why people, why mathematicians, or why scientists, or anyone using math, economists, the reason they're using calculus is for these reasons, is to be able to do this. So if you can do this, now here's the great thing. How do we know where a function is concave up or concave down? One statement. How do we know where a function is concave up?
Where it goes like.
Where what? Where the second derivative is, yes, has a positive value or is above the x-axis. That's it. The simple statement that goes with concave up is second derivative is positive. What simple statement goes with concave down?
Second derivative is negative.
Second derivative is negative. What simple statement goes with inflection points?
Where
the concavity
changes.
Where the concavity changes, where the second derivative goes from positive to negative or from negative to positive. Very simple,
Right.
right? What does increasing mean?
When the slope is positive.
When the slope of f of x is positive, where the first derivative has a positive value. When the first derivative is positive. So this was second derivative positive, this is first derivative positive. So increasing and concave up have similar qualities. Okay? Increasing means that the first derivative is positive, concave up means the second derivative is positive. What does decreasing mean? If the slope of f of x is negative, which means that the first derivative is negative. Yep. A relative minimum occurs where f of x
goes from negative to positive.
goes from a negative slope to a positive slope. It goes from decreasing to increasing, or where the first derivative changes from negative to positive. Right? And then a relative maximum occurs
Which goes from positive.
where the first derivative goes from positive to negative, or where f of x goes from increasing to decreasing. And now, in that whole conversation of this, didn't we just, and critical values are where the first derivative equals 0. So, in order to identify all of that information, you have to know how to identify where the first derivative and the second derivative are 0, positive, or negative. Does that make sense?
Yeah.
Which is why this list of abilities right here, this isn't that much. I'm not saying I'm going to, but I could probably, if my children who are 9 and 11 could understand functions, they don't understand them yet. They're learning. They're getting them. Okay? But if they understood what functions were, I could probably teach them this over Thanksgiving break. It's not that much. You could learn this if you're struggling on any of this stuff. But it starts with knowing how to identify the zeros of a function, where a function is positive, where a function is negative, and being able to do what? being able to identify the derivative of a function. Am I right?
Right.
Yeah.
So the inflection points are when the concavity is what?
Say it again. Oh, inflection points.
Yeah.
Where concavity changes.
Oh.
It's where the second derivative goes from positive to negative or from negative to positive. And when the second derivative changes from positive to negative, the concavity of f of x is changing from concave up to concave down. Does that make sense? It's all the same thing. That's all the same. Okay? Did I sum that up okay?
Yes.
You guys? Okay, so now do you understand why I'm obsessive about being able to find the derivative? Because you can't do any of this unless you first know the rules. You have to know the basic rules, and you have to know the product rule and the quotient rule and the chain rule to even start doing any of this stuff. But because this is the essence of what you have to be able to do in differentiation, you have to first be able to identify the rules.